All right, let's just throw out everything you thought you knew about reality for a minute. Because today we're putting physics itself on trial. Seriously. And in the doc, we've got this wild new theory, one that says the universe literally thinks itself into existence. Now, I know, that sounds like straight up philosophy, right? But the claim here is that this is testable science. And the charge? Oh, it's a big one, potentially rewriting everything we know about the cosmos. So the whole case really boils down to this one mind-bending question. Is the universe a kind of cosmic self-portrait? A thought that, just by the very act of thinking, brings itself to life? It feels like something you'd debate late at night in a dorm room, but the people behind this are saying, no, this is real, mathematical physics. So, you know what? Let's dig in and look at the evidence. So, the theory's central idea is what they call a self-witnessing universe. The argument goes like this. Reality isn't some passive stage that's just there, waiting for us to show up. No, instead, the very act of observation, of anything witnessing anything else, is what actually creates the stage in the first place. To make this idea less floaty and more concrete, the theory gives us a fundamental building block. It's called registration, or just R for short. I want you to think of R as the absolute most basic thing that can happen. It's like the fundamental pixel of reality. It's that moment when any distinction anywhere is witnessed as being distinct. And what's really crucial here is that this has nothing to do with us looking at things. It's a fundamental process that's just woven into the fabric of the universe itself. And what's really beautiful about this is that the whole core idea can be boiled down to this one super simple equation. WR equals R. W here just stands for the act of witnessing. So what this is saying is the act of witnessing a registration is the registration. That's it. It's a perfect self-contained loop. There's no deeper layer. You don't have to ask, well, what witness is the witness? Because the event and its observation are the exact same thing. Let me give you an analogy to make that really click. Imagine an artist painting a self-portrait, but this isn't some normal painting. The very first stroke of the brush hitting the canvas, that one act creates both the painter and the painting at the exact same time. The universe paints itself into being, and that very first stroke, that's the event of self-witnessing. That's R. Okay, so an elegant idea is one thing, but if you want to stand up in the court of physics, you gotta bring some hard evidence. So now, let's hear the prosecution's case. These are the parts of the theory that are rigorous, mathematical, and most importantly, testable. And this is where it jumps from philosophy to actual physics. This equation here is a direct, testable prediction. It connects h, that's the Hubble constant, basically the speed limit for the universe's expansion, to something called rho r, which is just the density of all those little registration events we were just talking about. All of a sudden, this isn't just an idea anymore. It's a number you can go out and try to measure. So what does that big fancy equation actually mean for us, like in plain English? Well, it boils down to three really specific predictions. 1. The universe is expanding at slightly different speeds depending on which direction you look. 2. This difference in speed isn't just random static. And 3, this is the big one, it's directly tied to how much stuff, matter and complexity is along that specific line of sight. And the best part? We can actually check this. We have the data to do it, like right now. But hey, no trial is complete without a tough cross-examination, right? For all its elegance, this theory has some really tough questions to answer. Critics have pointed out some major gaps that it's got to fill before anyone's going to accept it. So the first and maybe biggest challenge is right here. But where do the rules come from? I mean, if the universe creates itself with that first act of witnessing, where did the rules for that first act come from? You see the problem? It's that classic chicken and egg situation, and the theory has to have an answer. And that leads to this other really sharp critique about circular logic. The theory says the expansion rate depends on registration density, and that this registration density is basically proportional to matter density. But the critics are kind of going, hang on a second. Standard physics, Einstein's general relativity, already tells us that how matter is distributed affects how the universe expands. So the question becomes, is registration density some profound new idea, or is it just a fancy new name for something we already knew? And the list of problems doesn't stop there. There are other key concepts, like this thing called omega, this supposed undifferentiated potential that reality came from, that are still super vague. There's no formal mathematical proof that the core equation, W of R equals R, even has a real solution. And a bunch of the big master equations that are supposed to describe the physics, they're still just scaffolding, with really important parts left totally undefined. So yeah, the case seems kind of balanced on a knife's edge. But this is not where the story ends. What's so exciting about this is that there's a clear, actionable plan to get a final verdict. This isn't some debate that's going to go on forever. It's something that can be settled with real work. And this is that plan. It's a set of concrete, time-bound challenges. Like, within a week, scientists can test that Hubble prediction against real supernova data. Within 2 weeks, they have to define registration density in a way that proves it's not just matter density. A month to write down the full equations, and then 2 months to deliver that missing mathematical proof. The clock is officially ticking. So all of this work, all these deadlines, they're all driving towards one final question, which is really going to be the verdict in this whole trial. Has this theory actually made the leap from a beautiful idea to hard science? I think this quote just frames the stakes perfectly. Is the theory discovering something genuinely new and true about nature, or is it just inventing a new, maybe more poetic, language for the physics we already have? At the end of the day, the verdict comes down to one thing: predictive power. To be taken seriously as new physics, this theory has to explain something that our current models can't. A perfect example would be solving the Hubble tension. That's a huge puzzle in cosmology right now where different ways of measuring the universe's expansion give you different answers. If it can solve that, then wow, we have a serious contender. If it can't make a unique prediction like that, well, then it might just remain a beautiful piece of philosophy. And that's pretty much where we have to leave the case for now. The work on that timeline is happening as we speak. The data is being analyzed, the math is being double-checked, the trial is underway, and we're all just waiting for the verdict. So, will this elegant, self-witnessing picture of the cosmos become the next chapter in physics, or just a fascinating footnote? For now, we're going to have to wait and see.